Welcome to the module on flexible payments. Today we will be discussing about how to control the settlement of approach slabs. Before talking about the approach slab settlements, we will be defining what is an approach slab, and then we'll see what are the different methods available in order to have a better control on the approach slab settlements. So what is an approach slab? An approach slab provides a transition between the roadway pavements and the bridge. This generally gives a filling between the bridge part and the road which is connecting towards to the bridges. Approach slab acts as an intermediate bridge to span the portion of the embankment directly behind the abutment or the back wall, which was excavated to construct the abutment or the back walls. For example, if you see the photographs, like on the left hand side, you can see the face, which is a structure, maybe it's a PUP or VUP or a bridge structure, showing one end of the structure, and on the right hand side the line which is being demarcated with a orange line shows that when the road is being constructed, it has been constructed up to the right orange line initially along with the main carriageway, and then this gap which is being demarcated with the orange line is being filled up after the completion of the bridge. So this is the portion which is actually a intermediate span which is getting filled up after the completion of the bridge. Then to construct the approach slab, you need to have a PCC on the gap between the bridge face, the back of abutment wall or the back wall, and the existing road. And then this will be covered with a RCC slab of say 300 millimeters thick, and maybe around 3 meters or 3.5 meters in length along the line of cross section of the road pavement. So this is the slab which is generally known as the approach slab, which is acting as an intermediate bridge or covering the span between the existing structure and the roadway which is meeting or approaching the structure for completing the project. How to control the settlement of approach slabs, or how to reduce the bump while approaching a bridge or a structural member during the travel on the road surface, because it is seen that irrespective of the fact whether it is a ordinary road or a district road or even if it is an expressway, the bumps while approaching the bridges are unavoidable. So this is generally creating a driver's discomfort, and especially for expressways where the speed of the vehicle is very high, to the tune of say 100 kilometers per hour or 120 kilometers per hour designated speed, and the actual speed is much higher than what is being denoted, the chances of accidents are high if you have a sudden bump while approaching the structures. So it is mandatory and required to understand the ways to control the settlement of approach slabs and reduce the humps or eliminate the humps close to approach slabs. So a number of procedures exist that will reduce the differential settlement at bridge abutments, assuming its causes is some sort of a soil compression of either the embankment fill or the foundation soils. Sometimes the erosion also plays a major role as far as the settlement of the approach slabs is concerned. Sometimes the weep holes provided on the walls of the abutments, which are left unattended with a geotextile membrane from the backside, allows the soil to move out of the weep holes, thereby reducing the thereby allowing the approach slabs to settle, because there will be an unforeseen voids being created between the bottom of the approach slab and the top of the soil within the approach slab areas. So the different methods which can be adopted are you can provide a support to the approach slab at the free end. You can change the construction sequence, or pre-compression and lightweight fills use will have any better impact on the control of the approach slab settlements. In this module, we will be talking mainly on these three aspects only, though there are other methods like foundation soil consolidations can be done in order to reduce the approach slab settlements. A pre-cambered approach system is also available, which we will be discussing in the upcoming modules. Then the approach fill stiffening, which is basically a sort of RE panels construction while approaching the structures. It can be a major bridge, or it can be a PUP or a VUP systems. And then there will be a buried approach slab at a depth of 610 millimeters from the top of the deck slab is also in practice, or a preformed grout holes are also used commonly in order to reduce the settlement of the approach slabs. But today we will be talking in detail about the first three, which is providing support to the approach slab, a change in construction sequence, and a pre-compression and lightweight fill materials. So providing support to a approach slab, this is nothing but you can provide a support of a sleeper beam or a structure concrete member at the free end of the approach slab, which is as shown in the figure. What happens is by providing this, you are converting the approach slab, which is generally a cantilever type member, to a simply supported member, as it is being supported on both the sides. One end is being supported by a sleeper beam, and the other end with the notch or a type of a seat which is being provided on the bridge. So what happens is when the vehicle moves on top of the road, at this junction where the approach slab starts, generally it tries to get pressed in the downward direction if the consolidation of the soil or the compression of the soil is not proper, thereby lifting the free end, and then the hump is being created. So by providing the support, what is happening is the impact on the impact of the wheel when it moves from the flexible surface to the rigid surface is being reduced. Now, the second method is a change in a construction sequence, a simple method of applying a consolidation load to the soil prior to the construction of the bridge approach by enforcing a time period of waiting between the embankment construction and the approach slab constructions. That means once the embankment fill is being made between the gap being provided by the embankment, existing embankment, and the end of the structure part, the approach slab needs to be constructed with a waiting period, so that whatever the compression or the consolidation is bound to happen, it will happen there only. Or generally you can supply flush the surface with water, so that the compression of the soil can be achieved. Approach slabs shall be constructed with the construction of the paving instead of the bridge progress. Like this will delay the construction of the approach slab, because once the paving starts, the final layers of the roads starts, by that time the sufficient time is being provided in order to get compressed the embankment and the subgrade top of the soils. So whatever compression the local settlement is bound to happen, that will happen there only, and then once you construct the approach slab, there is no much scope of the local compression. Proper drainage of surface water needs to be planned with the construction of the approach slab. That means as soon as the approach slab is being constructed, it should be ensured that the road which is generally acting as a catchment, especially in the sloping areas, should be provided with a proper drainage, because if not, then the bridge locations or where there is a gap between the curb and the bridge is acting as the weaker points for the water to move out. So if the drainage system is proper, then it will not help to erode the soil which is underneath the bridge. Slope protection shall be completed to restrict the erosion of the soils. Possible water intrusions through the approach slabs shall be restricted. And the median filling needs to be completed with the completion of the approach slab, because what happens is, if on the left hand carriageways and the right hand carriageways are being covered with approach slab and the median is not being covered with the rigid materials, then the soil which is being filled in the median portion is exposed to erosion or formation of a cavity because of the problem associated with compression or the compaction of the soil. So quite possibly a cavity can be formed from the median, which may run across the cross section of the road to the edge. So the cavity which is being formed from the center of the road to the edges of the road will help for the approach slab to settle. So it is required to fill all the materials, to fill all the gaps which is being covered with the approach slab with the rigid materials. So if you see the examples, like generally we provide the wing walls with the structure. Now wing wall has the problem associated with the wing wall is it is being constructed in a sloping direction, which is moving away from the cross section of the road. So what happens is you have a weaker section or a weaker zone which is in line with the wall of which is in line with the wing wall, and thereby the possibility of erosion of the soil is higher. But if you produce a return wall instead of a wing wall, which is as shown in the figure, then the area is being confined with a return wall on both the sides of the structure, and then the existing road which is coming from the other end. So whatever fill material is being placed in that pocket, which is confined from all the four sides, will not be prone to erosion or any soil movement is possible. So the chances of the settlement of the approach slab is minimum. So generally what happens is approach slab doesn't settle because of its weakness in the strength, rather than because of the formation of the cavity below the approach slabs. So if we are able to control the cavities being formed below the approach slab, we will be able to control the settlement of the approach slabs. So a CHUTE drain can be provided along the line of the wing wall as shown in the figure, because generally what happens is the ends of the approaches or the ends of the bridges which are prone to water impact when rain comes, because because your main carriageway is the catchment, as it is being confined from both the sides with a curb, and if the curbs are not terminated when it approaches the bridge, that means those are the points of discharge of the water and will impact your sloping end of the bridge along the wing wall and will help to erode the soil. So once the soil is being eroded across the line of the wing walls, if you allow traffic on top of the road, then the vertical load will have an impact to displace the soil below the road in the horizontal direction, thereby creating a cavity between the bottom of the approach slab and the top of the soil. So a proper drainage needs to be formed so that whatever soil, whatever water is being accumulated close to the bridge at the crash barrier locations should be discharged through a proper drainage, and will be connected to the main line or the main drainage of the road on both the sides. But the size of the drain needs to be decided depending upon the flow of water, and the type of the pipes needs to be decided depending upon the flow of the water. Not necessarily everywhere you can have these small pipes, but the drainage system has to be properly designed based on the discharge of the water which actually has. So as far as possible, it should be properly connected to the main drainages as shown in the figure, because you can see that there is a culvert at the end, but it is being clogged properly. That means there is a very little scope to discharge the water once being collected through the CHUTE drain as provided on the main carriageway. So one has to make sure that the CHUTE drains are being properly connected to the main drain, so that the discharge of the water has to be from the start point to the end point without any stoppage, because the moment you try to stop the water, it will create the catastrophic effects, thereby erosion of the soil will take place. Once the erosion of the soil will take place, even if it is from the bottom layer of the soil, it will have a direct impact on the top of the road, which will be in the form of a settlement. So the different types of CHUTE drains are being provided along the line of the wing wall as shown in the figure, but the challenge is you cannot fold your drains as per your wish, because the water will not move as per your directions, rather it has to move in its own way. So one has to make sure that the drains has to be along the line of the flow, not in the turning points. And if at all we want to have a turning like this, then the turn area needs to be properly closed with a complete circular pipe, so that there will not be any spillage of water out of this pipe. Because in this current scenario, what happens is the water will not turn as per the wish of the engineer who has made it, rather it will go straight and have an impact on the stone pitching which is being laid on the side slopes. So what will happen is, even if you have provided a drainage like this, it will not serve its purpose, rather than it will also have an impact on the erosion of the soil on the stone pitchings. As you can see that some of the stones are already settled because of the erosion of the soil below. So it is always required to close the curb lines which are close to the structures, whether it is a PUP or a VUP, properly closed, and should be directed straight as far as possible for the discharge of the water to be out of the road purview areas. Once that is being done, you can further do like you can cover the sloping areas close to the wing wall, the triangle which is being shown here. It can be properly covered with a concrete portion also, so that this area being the weakest area as far as the compaction is concerned, if covered properly with concrete, the water will not get penetrated below, and the chances of erosion will be less. So in the triangular portions, the stone pitching shall be filled with a dust or a plain concrete to protect the erosion of the soils as shown in the photograph. Areas like you can see that these are the different types of drains which is being provided in some of the projects, but the problem associated with such drainage is water will not move as per our wish or as per our directions being provided to them, because in this photograph you can see that the water is entering and then it's taking a sharp turn and then reaching to the final discharge point. But during the process, what is happening is the turn where it is being provided manually, if the discharge is more, the water will simply flush out of the drain and will hit the area which is prone for discharge erosion of soil. So My suggestion is wherever we want to have a turning effect as far as the drainage is concerned, the turning needs to be associated with a complete circle of the drain, so that the water entering into the drain will not flush out of the drain at any point of time. So these are some of the photographs which indicates that how neatly the curves are being designed and how the water is being directed along the line of the curve and is being discharged from the sides of the crash barriers in the bridges to meet the main drainage of the roads. Coming to pre-compression and lightweight fields, according to Bowles in 1988, pre-compression may be used to accomplish two major goals. One is to eliminate the settlements that would otherwise occur after the structure is built, and second is to improve the shear strength of subsoils by increasing the density, reducing the void ratios, and decreasing the water content. Ball states that pre-compression is a relatively inexpensive, effective method to improve poor foundation soils in advance of construction of permanent facilities. A reduction in the increase in pressure felt by a foundation soil due to embankment constructions will also decrease the settlement's potentials. Loading may be reduced through the use of lightweight fills such as lightweight aggregates, expanded polysterenes, lightweight concretes, fly ash, or a cyclone test even, and finally the sand which is being consolidated using the water. So to summarize this module, we talked about the definition of the approach slabs, the different methods to control the settlement of approach slabs, the impact of differential settlements on the safety of the drivers. Thank you.